The cis-isomeric form of lycopene found in watermelon is mechanically distinct from the trans-isomeric form in tomatoes, allowing for significantly higher bioavailability and absorption in the human intestinal tract.
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello and welcome to Dr. Mercola's Cellular Wisdom.
When you look at the standard nutritional literature regarding lycopene, you almost exclusively see tomatoes pushed as the primary dietary vector. But looking closely at the actual molecular geometry, well, it changes the entire equation for how we utilize this antioxidant.
We're taking a deep dive into a very specific, almost clinical-grade protocol today for you. It involves consuming 2.5 to 3 pounds of watermelon daily.
It sounds like a massive volume, and to be fair, it is a significant amount of food. But the therapeutic outcomes tied to that specific dosage are profound once you break down the intestinal transport mechanisms.
Let's start right there with the lycopene paradox.
Yeah.
People hear lycopene and they instantly picture tomato paste or marinara sauce. But the trans-isomeric form in raw tomatoes is essentially a rigid linear carbon chain,
Which creates a severe packaging problem in the human gut. For any fat-soluble nutrient to successfully cross the intestinal wall and enter the lymphatic system, your body first has to encapsulate it into micelles.
those microscopic lipid transport vehicles.
They are essentially tiny spherical cargo ships made of bile salts and lipids. If you try to force a stiff, straight transisomal molecule into a tiny round micelle, it physically resists. It precipitates out of the solution because it just doesn't fit the curvature.
But the cis-isomeric form, abundant in watermelon, has a distinct structural bend in its carbon chain.
It has a kink. Because of that kink, it curls up and packages efficiently into the spherical micelle. Nature already optimized the geometry. You don't have to thermally degrade or cook the fruit to force a structural change like you absolutely have to do with tomatoes to get any meaningful absorption.
Because you're absorbing it so seamlessly, the dosage delivered in this protocol becomes incredibly potent for your system. A standard therapeutic dose for cardiovascular optimization in clinical literature usually hovers around 10 to 30 milligrams a day.
But by strictly adhering to the 2.5 to 3 pounds of watermelon protocol, you are ingesting between 51 and 80 milligrams of highly bioavailable lycopene.
You are systematically saturating the lipid pathways. We focus so much attention on absolute LDL numbers on a blood panel, but the actual pathological trigger in vascular disease is the oxidation of that LDL particle.
The structural degradation of the cholesterol transport vehicle itself. Once LDL oxidizes, the immune system no longer recognizes it as a nutrient transporter. Macrophages engulf it, turning into foam cells, which then embed into the arterial wall. That is the genesis of plaque.
Because lycopene is intensely lipophilic, meaning it binds tightly to fats, it physically embeds itself right into the LDL particle.
Saturated at 80 milligrams a day, it acts as an embedded structural shield. It intercepts the free radicals before they can degrade the lipids, directly mitigating the specific oxidative trigger that turns a benign transport vehicle into a vascular risk.
That structural protection pairs seamlessly with the hemodynamic shifts driven by the citrulline pathway. We're moving from antioxidant shielding to active vasodilation here.
Watermelon is the richest naturally occurring source of the non-essential amino acid citrulline. The metabolic routing here is fascinating because it solves what biochemists call the arginine paradox. Oral arginine supplements are heavily marketed for blood flow, but they have a severe metabolic limitation.
The hepatic first-pass metabolism. The liver essentially intercepts the arginine before it can do any good.
The liver is saturated with an enzyme called arginase. Arginase degrades oral arginine almost immediately into urea and ornithine, preventing it from ever reaching systemic circulation in meaningful amounts. Citrulline, however, lacks the molecular binding site that hepatic arginase looks for, so it bypasses the liver entirely. It travels safely through the hepatic portal vein directly to your kidneys,
where the kidneys efficiently convert it into arginine and release it straight into the bloodstream,
producing significantly higher plasma arginine levels than if you had just swallowed an actual arginine supplement. This plasma arginine is the direct chemical precursor to nitric oxide. The endothelium, the delicate inner lining of your blood vessels, uses that nitric oxide to signal the surrounding smooth muscle tissue to relax,
which dilates the vessel and drops systemic vascular resistance. In fluid dynamics, it's Poiseuille's law. Increasing the radius of the tube massively increases the flow. It's the difference between forcing water through a narrow, rigid garden hose versus a wide-open industrial pipe.
The mechanical workload on the heart plummets. We see this exact physiological response documented in the American Journal of Hypertension, where aortic blood pressure drops significantly following citrulline-rich interventions. And it isn't just cardiac relief. Every single tissue dependent on perfusion benefits immensely.
Oxygen delivery to the brain enhances cognitive function. Nutrient shuttling to skeletal muscle extends exercise endurance. And erectile function, which is a purely hemodynamic process, is directly supported by this pathway.
It all comes back to endothelial pliability and nitric oxide signaling. But maintaining that expanded vascular volume requires highly specific fluid dynamics. This protocol provides nearly a liter of water, but it's intracellular water.
It's structurally entirely different from drinking a liter of free water from a glass, which often triggers an immediate diuretic response from your kidneys.
Free water lowers blood osmolality very rapidly, prompting the renal system to excrete it almost as fast as you drink it. It's a quick flush. The water in this fruit is trapped within a complex cellular matrix of specialized fibers, sugars, and electrolytes.
As you digest the matrix, the water is released gradually. It functions as a slow-drip physiological hydration mechanism,
Delivering a massive electrolyte payload simultaneously, particularly potassium, which we are facing a severe population-wide deficit of. The recommended daily intake sits between 2,600 and 3,400 milligrams.
The average individual gets nowhere near that baseline requirement.
This daily protocol delivers up to 840 milligrams of potassium in a highly bioavailable, enzyme-rich state.
Acting as the primary intracellular cation, running the sodium-potassium pump in every single cell of your body.
That pump requires constant ATP energy to physically push sodium out of the cell and pull potassium in. This maintains the resting membrane potential. When you are deficient in potassium, the cell membrane becomes electrically unstable, leading to erratic contractions in the vascular smooth muscle and higher blood pressure.
So you have a very elegant dual-action cardiovascular intervention here. The citrulline chemically induces the vessel to dilate via the nitric oxide pathway, while the potassium electrically stabilizes the cellular rhythm and the blood pressure.
They work in perfect tandem. And while your kidneys are actively processing that citrulline and potassium, they are also benefiting from the mechanical flushing action of the high fluid volume.
The high volume of dilute fluid prevents the localized crystallization of stone-forming minerals in the urinary tract. If the urine-specific gravity remains low, stones simply cannot form.
The kidneys and liver are also uniquely leveraging the citrulline for the urea cycle. This is a critical point for nitrogen disposal, especially for anyone maintaining higher protein intakes. Protein breakdown inevitably generates ammonia as a metabolic byproduct.
Ammonia is fiercely toxic to all biological tissue, particularly delicate neurological tissue.
The urea cycle is the dedicated biochemical pathway responsible for converting that highly toxic ammonia into benign urea for safe excretion. Citrulline is the rate-limiting catalyst for this entire detoxification cycle.
By saturating the system with citrulline, you are directly upregulating the biochemical machinery responsible for clearing toxic nitrogenous waste. It's not a vague concept of a detox. It is a highly targeted, measurable metabolic detoxification.
Alongside a profound and measurable reduction in systemic inflammation. The fruit contains a highly functional triterpene called cucurbitacin E. When you track systemic inflammatory markers on a blood panel, specifically C-reactive protein, cucurbitacin E acts synergistically with the high-dose lycopene to suppress those exact inflammatory cytokines,
lowering the baseline inflammatory load that drives nearly all degenerative pathologies. And that systemic cellular protection extends seamlessly to ocular health as well, utilizing beta-carotene and lutein.
Lutein physically accumulates in the macula of the human eye, right at the center of the retina. It functions as an internal optical filter against high-energy blue light and oxidative stress. By actively neutralizing free radicals generated by light exposure, it directly mitigates the biological mechanisms behind age-related macular degeneration.
It also has an impressive, scientifically validated utility for muscular recovery. We already detailed the hemodynamic benefits for exercise endurance, but post-training, the natural sugars rapidly synthesize and replenish depleted glycogen.
While the sustained citrulline levels accelerate the clearance of metabolic byproducts like lactate from the muscle tissue, research highlighted in the Journal of Agricultural and Food Chemistry clearly demonstrates how the specific citrulline pathway drastically reduces delayed onset muscle soreness and normalizes recovery heart rates.
Executing this requires adhering to highly specific parameters. You cannot simply drink a quart of pasteurized commercial juice. and expect to trigger these precise physiological responses.
Juicing aggressively strips the cellular matrix. You lose the structural fiber, which completely obliterates the slow-release hydration effect and violently alters the glycemic response. The protocol firmly demands consuming the fresh, intact flesh, ideally split between morning and afternoon servings.
And variety selection matters immensely. We're selecting deep red flesh, which indicates peak lycopene density, and specifically seedless cultivars.
Seedless variations biologically reallocate the plant's metabolic energy away from seed generation directly into synthesizing much higher concentrations of lycopene and citrulline in the surrounding flesh.
For anyone concerned about consuming 3 pounds of fruit regarding blood sugar mechanics, we have to distinguish carefully between the glycemic index and the glycemic load.
The index is technically high because the carbohydrate structure is relatively simple, but the actual glycemic load is extremely low. At 92% water by weight, the absolute carbohydrate mass per standard serving is minimal. The intact fiber matrix slows intestinal absorption, heavily blunting the insulin response.
It also triggers a high degree of mechanical satiety. You're consuming a massive physical volume for roughly 350 to 420 calories.
It relies on the strategy of volumetric displacement. The gastric stretch receptors in the stomach wall signal profound fullness to the brain, which naturally and effortlessly displaces calorie-dense, nutrient-poor processed foods from the daily diet.
There is an evolutionary mismatch argument we have to address head-on. Ancestrally, human populations did not have year-round access to massive quantities of high-sugar, water-dense summer fruit.
Consuming a cooling, hydrating fruit during a dark winter freeze absolutely violates historical seasonal eating patterns. But that ancestral paradigm assumes we are still living in an ancestral environment,
Which we clearly no longer inhabit. Our modern environmental stress load is completely unprecedented in human history.
We are constantly navigating chronic oxidative stress from artificial lighting, pervasive environmental toxicants, and systemic vascular stiffness from highly sedentary lifestyles. The sheer therapeutic density of the lycopene and citrulline specifically counters these exact modern pathologies.
The high-dose functional intervention significantly outweighs the theoretical downside of departing from ancestral seasonal availability.
We're intelligently applying a potent nutritional tool to combat a highly unnatural, modern environmental load. The intense vasodilation, the lipid shielding against oxidation, the accelerated ammonia clearance, these are necessary metabolic adaptations to our current reality.
It operates as a calculated daily orthomolecular intervention seamlessly delivered using a whole food matrix.
But delivering highly targeted cardiovascular and renal support with a biological efficiency that isolated synthetic supplements simply cannot replicate due to hepatic metabolism and structural incompatibilities.
Thank you for listening to Dr. Mercola's Cellular Wisdom. See you in the next episode. Looking for trusted health wisdom you can hold in your hands? Discover the life-changing books of Dr. Mercola at joyhousepublishing.com. These titles bring decades of natural health research into practical steps for better energy, stronger immunity, and clearer thinking. Take charge of your health with guidance rooted in science and experience. Visit joyhousepublishing.com now and claim your bonuses while they are available.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.